Welcome, ladies and gentlemen, to section 1.5 Reflections. This lesson is not quite as long as our past lessons with transformations because there's only two ways to have the reflections appear, either affecting the graph vertically or horizontally, and there's not much wiggle room in terms of what it could look like. So it's not quite as long, but this is the last transformation we are going to learn about before we really get into putting multiple transformations together from everything we've learned from 1.3, 1.4, and now 1.5. So to begin, vertical reflections. This is the first thing you're going to want to highlight, vertical reflections. If g of x equals negative f of x, then the graph of g is obtained from the graph of f by reflecting over the x-axis. So if the negative is on the outside of any grouping symbol, which is then affecting the graph vertically, it's going to reflect it over the x-axis. Because if you think about, if I were to draw a graph, and let's say I have a box, just to give us a shape versus, a function. If I have this box and I'm reflecting and making all of my y values, which are once positive, now negative, my box is going to end up down here. I'm sure you've done this in geometry, and this might be a little hard to read, but my box is down here. This would be my new box. And that reflection is a vertical movement. I'm starting from the top and I'm reflecting over to the bottom. But what I'm reflecting over is the x-axis. We've been talking about rules in the past couple of lessons. The way the rule would look for a vertical reflection would be like this, where the negative is affecting the y value. Suppose, for example, that f of 2 equals 3, so the point 2, 3 is on the graph of f. Since we have this negative being multiplied by the f of x, that would mean we have a negative 3, so the reflection happens over the x-axis. So this is just another visual instead of the box example I gave you here, but it says the same thing. Next, we have a horizontal reflection. Notice that the negative is inside the grouping symbol. Remember, anything happening inside your grouping symbol is going to affect the graph horizontally. Usually we use the phrase if x's always lie or it does opposite in reality of what it says it does. This is the one instance where a negative is not like an addition or subtraction or a multiplication or a division. The negative is just saying that it's a reflection is happening over the y-axis. If you were to write a rule for this horizontal reflection, if that was the only thing happening, it would be negative x. If it's helpful for you to remember that x's always lie or x's are always the opposite operation in reality of what it says, you could interpret this as a negative 1 times x, and then you could say, well, we would divide by negative 1 here instead of multiply, if that is helpful for you, but you don't have to. Just know that it's affecting your x value. So we have one problem that we're going to go through to really talk about reflections. It says graph the functions f of x equal x minus 1 quantity squared and h of x equals negative of this function f of x. Now, note that both of these, before we really even get started with h of x, this f of x function, x minus 1 quantity squared, has a parent function. And so you've seen this set up on your homework assignments before, but the first thing is it's saying, what is the parent function? And we want to know what is the parent from the beginning before we do any transformations, because this has a transformation in it. So before this function happened, where did it originate from? What is its parent? That's what the exponent is telling us. This squared is telling us that the parent function is x squared, or you could say quadratic. Then it wants a description. Well, let's first give a description of f of x, and then we'll talk about h of x. So let's think about in f of x, what is happening here? Well, we have this minus 1 that's happening inside the grouping symbol. Happening inside the grouping symbol means it is pushing the graph forward or to the right 1 unit. So using that information, that means this f of x table here is going to be just like the x squared table, but all my x values are going to be moved up 1 unit. So that would give me this table here. One, 0, 1. Why do I have an extra one here? No, I'm not going to use this bottom one. I just have an extra cell down here. Kind of took me off guard. All right, and then my y values are going to be just like what they were from the parent quadratic function. So if I were to graph this, this is what it would look like. And so you can see that the shape is a parabola, and it looks just like the parent quadratic function, except my parabola is 1 unit towards the positive side of the x-axis. Now, ultimately, this question is all about the lesson, which is dealing with reflections. So we needed to do a little bit of this work to get an understanding of what this graph looks like. Now, let's talk about h of x. H of x says it's negative f of x. So if I were to write this out, not using so much of this notation, it would be negative x minus 1 squared. So that negative would be located here out front of the grouping symbol, because notice it's out front of this f of x notation. Now it's outside the grouping symbol, which means it's affecting the graph vertically. A vertical transformation and a vertical reflection means we're reflecting over the x-axis. So in the next part of our description, we are going to say reflect over the x-axis. And I know it's a reflection over the x-axis because of where that negative is located. And just to remind you, I know that it is to the right 1 unit because of where that minus 1 is located. So what that means for me is that all of these points, I'm going to reflect over my x-axis, which means all of these values that had positive y numbers are now going to be negative. That's the only thing that's going to change. So my x's are going to stay the same. But my y values are all negative. Because now when I go to graph them, you're going to notice that it's a mirror image over the x-axis of this one we have in purple. We have one more problem to go through, and that would be example 2. Now, this example problem, you might have seen some of these in the homework prior to this, but it says find a function whose graph is. And so what we want to do is we want to come up with the rule and what the function would be with the transformations applied to get this parabola. Well, the first thing we need to notice and figure out is, what is the parent function here? Look at the shape of this graph. What does it look like? Well, it's a parabola, so it looks like quadratic. So I know right off the bat I have something that is quadratic, and that's telling me I'm going to have something squared. Now I'm thinking about, okay, originally a parent quadratic function is looking something like this. So how am I getting from this to here now in blue? And so I'm going to pick a point that I'm going to start with on the parent function and figure out how do I move that point to get to the new one. And the most easiest point to use for a parent function is the point of origin, and right here at the point 0, 0. So I'm going to focus in and think, all right, this point 0, 0, how do I then map it to the new one? So I'm going to go back until I feel like I'm right above it, which means I'm going to go back 3 units. Then I have to think about, well, how far down do I have to go? And this is just kind of a rough approximation, but it looks like I have to go down about 1 unit. So it looks like I have to go back about 3 and down about 1. And this is just kind of roughly approximating what it looks like. Maybe it's more like 1.5. It's kind of tough to tell, but. So once I figured out, okay, I have to go back and I have to go down, my parabola started opening upwards, but now it opens downwards, which means a reflection happened over the x-axis. From here, you might be able to come up with what the new function looks like, or what I usually like to do is I like to create a rule first and then use that to create my function. So if I were to create a rule for this new function to get from the green graph to the blue one, I'm noticing that in terms of horizontally what's happening, I'm going back 3 units. So that would be x minus 3. Vertically, I'm going down 1 unit. And I have a reflection over the x-axis, which means my y is now negative. So creating my function, I don't know, let's just give it a name like f of x. I know inside a grouping symbol, it needs to say x plus 3. You might be wondering, well, why x plus 3? Because remember, the rule and what the function reads as are opposite in operations. So I know it went back 3 units, but that means my function is going to say plus 3. My parent function is quadratic, which means this quantity is going to be squared. To represent this negative in front of the y, I'm going to put it in front of my parentheses here. And this minus 1, this shift of down 1 unit, is going to go here. So doing some highlighting just so you can see, the minus 1 is because it's going down 1 unit. The plus 3 is because we're subtracting 3 or going back 3. The negative is because it's a reflection. And the squared is because the parent function is quadratic. And that concludes 1.5. You are now good to move on to the 1.5 assignment.